I'm Omid Hassasfar. I'm originally from Iran, and at the moment, I'm basically finishing my PhD in quantum biology at Stellenbosch University in South Africa. My background is physics, and from physics background, I decided to basically work in this interdisciplinary field. In the hackathon, the first quantum biology hackathon, I was the team leader of Africa and Middle East. The project that our team focused on was, we have different flavor in quantum biology. That one flavor of quantum biology is vibrationally assisted tunneling. And our project was to investigate if there is any effect on the connection between vibrationally assisted electron tunneling to drug discovery, and specifically the efficacy of the process of drug discovery. Originally, this idea was proposed for olfaction or sense of smell, but we decided to generalize the idea. And basically, in my PhD, part of my PhD, I'm working on this project to see if we can generalize this idea from sense of smell to other types of receptor in our body. And about the people, we have some people from different backgrounds. Actually, we had chemists, we had physicists, 2-3 physicists, and also biologists. And that was very interesting because people from different backgrounds could have potentially different approach to tackle one specific problem, and also people were from different countries as well. We have people from myself from Iran, and people from South Africa, people from India, Algeria. But it was very short notice. I'm 100% sure next year we will have more people from more countries. Yeah, one thing that I really like about that was when I talk to my mentees or people who attended as a Africa, Middle East, they had different background. And when we discuss about our specific problem, they propose some different approach to tackle this problem. Our brainstorming part was very interesting for me because different people had different ideas. For example, I'm as a physicist, I never looked at this problem as a chemist point of view or as a biologist point of view. So I was the leader of the team, but I was also learning a lot of new things. I also proposed the idea to the chemists, to the biologists. Also, they were really surprised that people from quantum physics background can think about this drug discovery process and can be involved, because they thought usually medicinal chemists are working on this type of problem, but they were a little surprised about how we quantum physicists can also think about these types of problem based on our computational results. Of course, this was preliminary results because we only had 2 days, but some basic results that we got was a little surprising, because based on the vibrational spectra that we got from different potential drugs, we got different tunneling rates, which was interesting for us to see that the vibration has effect on the tunneling rate here. First of all, of course, collaboration. Usually people work in their group and they don't, in their master's or PhD or postdoc, they don't have enough time to collaborate with probably different group from different part of the world. So first of all, collaboration, and people from different background can talk to each other, can work on a specific problem, and can tackle that specific problem from different backgrounds. Hackathon or hackathons, not only quantum biology, I participated in different hackathons. That was not of course, that was the first quantum biology hackathon, but I have participated in many different hackathons, including quantum computing, AI. And the most important things is here, in my opinion, is the collaboration with different people from different backgrounds and different countries. In hackathon, usually the speed is very important. Okay, everything is fast paced. So in 2-3 days, you need to define your project from idea to code, because that was not experimental hackathon, it was like a theoretical computational hackathon. So from idea to code, it should takes usually 2-3 days. So this fast-paced approach was something that I think if you ask each participant, okay, you don't have enough time to ask all of them, but as a team leader, I can tell you, everyone, when they participate in a hackathon, they realize this is a different types of learning. Because when you are a master, you have 1-2 years. When you are PhD, you have 3 years, 4 years, 5 years. But when you participate in a hackathon, you only have 2, 3, or 4 days, and you need to define your project, implement it, and present it. So that fast pace is, I think, of course, collaboration that I mentioned in the previous question also is important. But yeah. Because I participated in person in Berlin, Germany, and I definitely saw people who are active, very active in quantum biology. That was the first thing I really liked it. And the second things I can say, the energy and the momentum that was in these 2-3 days. And we wanted to compress everything and then present it. And yeah, all of them was very, very great experience for me. And I'm really looking forward for the second Quantum Biology Hackathon. Yeah, the next step, we can have different approach. For example, if we can find people in machine learning, we can extend our model with a big data set. If you have a big data set, you can find some pattern. Even if you cannot explain what's going on, you can find the pattern. So that can be one extra step. So if I want to extend our model, that's something that I really like to do. That is doing that machine learning model, deep learning model with a big data set to find the potential pattern for the vibrational spectra. The other things that we can expand our project is collaboration with the experimentalists, because at the end of the day, no matter how good your theory is, you need to find some experiment to prove or refute it, and that can be also another avenue for our project. These days, machine learning, AI, deep learning, large language model, generative AI, all of them has application in, I think, all different fields of biology, chemistry, physics. Basically, quantum biology, that, it's a very niche field, and we have some specific type of problems. As I mentioned in the previous question, it definitely can help us if we have enough data set. If we have a big data set, definitely can help us to find some pattern, at least in the data that we have, okay, whatever it is. For example, if it's like an effect of magnetic field on the living system, if we have enough data set, so which is difficult for human to analyze it, it can definitely help us. If in my project, if I have like a 2,000 different molecules, that I have the vibration of those 2,000 molecules, okay, it's impossible for human to analyze them. So we can use and develop, basically, it's not very easy, okay, it takes time to develop some models to analyze it and find the patterns. And then if we have the pattern, if we have some nice categories of different molecules, so then we can have some insight that which direction should be more be focused to find the underlying mechanism of those phenomena in living systems. Yeah, the whole experience, I like the energy, I like the vibes. The room that we had was very nice, big, and we have screens. So because there are six different regions. I think there were five of us, and 2 people were completely online, not hybrid. So If I wanna like suggest something, it would be great if we could have like some participant also in person. So because we were only leaders, okay, and each leader we're working in their group separately. So that would be great if we next time we can have some of at least the participant in person as well. But generally it was very great and my idea. And then yeah, everything was very nice. Yeah, that's a very interesting and important question. First of all, based on my experience in this hackathon specifically, we need to basically define our field specifically, because many people that approached us, and they were expecting that we are going to have a quantum computing hackathon. So they mentioned, okay, are we going to work with IBM or I don't know, Google or some other companies? And when we said no, this is not a quantum computing hackathon, this is quantum biology hackathon, and we spent time to describe, okay, this is quantum biology, that's the definition, that's the typical problem that we do care about, solving those problems, that we think that a non-trivial quantum mechanical property can help us to describe those phenomena. That one thing that I really like that people to understand, that the field itself, because it's a niche field, the community is still small in comparison to, for example, AI, or for example, quantum computing or other standard field that we have. This is something that I really like to do. Yeah, I think that's the most important things. And then collaboration. The collaboration is also very important because this is an interdisciplinary field. Physicists, biologists, chemists, computer scientists, even. As I mentioned, so now we need also AI experts in this field as well. So people need to talk to each other as well. I mean, experts even, because usually biologists work together, chemists work together, physicists work together. And this talking of all these groups together is very, very important in my opinion. And it takes time, but I think that is necessary if we want to achieve like a great accomplishment in this field. We definitely need to spend time and learn from each other. The pace in hackathon is very fast, and this is a new types of learning. So, but also is important because sometimes you need to have some like deadline to work under pressure. So if I tell you, okay, you have 1 year to solve this problem, you usually spend the last 3 weeks to solve it. So sometimes I think this type of events like hackathons can help us to work under pressure and to learn how to work under pressure and collaborate as well. So it's not only working under pressure, you need to work under pressure and collaborate with your different people. Even if you are a mentor or you are a mentee, doesn't matter. You need to learn how to collaborate. This is also very, very important. I thought before, I'm not talking about specifically this hackathon, but in my previous experience, before that, I thought that it's something trivial that everyone knows, but it turned out that this is not true. Some people prefer to work alone, and it's not something trivial. Sometimes you need to teach people how to collaborate. I didn't expect that. I learned it in the experience of hackathon.